Today we will be building from our understanding of learning target 9A, which was adding, subtracting, and multiplying polynomials, and we will be adding to it the ability to look at polynomials given the context of a situation and apply those same three skills. The first thing that we want to look at being able to do is to write a polynomial expression for the perimeter of a given shape. So here we have a given shape that's not a traditional square or a traditional triangle. It's a couple of rectangles that are put together. What we need to do first is we need to be able to identify the two missing side lengths. So the first thing I see is that we have a missing side length here where the red question mark is. Now, in order to figure out what that is, we know that this top length here, all of this, is 2x plus 10. We also know that this part on the bottom down here is x plus 3. So we know that this red question mark must be the difference between those. So we can write 2x plus 10 minus x plus 3. Now, if we follow the same steps we did in 9a and distribute the negative sign, we get 2x plus 10 minus x minus 3. So then we can simplify that part to 2x minus x gives us 1x, and 10 minus 3 gives us plus 7. So we know that that side is plus 7. Now we're going to do a similar process here for the side where we have the blue question mark. But in this case, we know that our long side here, stretching from there to there, is 3x, and we know that the portion of it is from there to there, which is 10. So we can say that the short side must be 3x minus 10. Now, because we can't simplify 3x minus 10, we know that that has to be this length in terms of our shape that we have in front of us. Now, if you remember correctly, perimeter is all of these side lengths added up together. So let's make a little note of that. Perimeter equals all of the side lengths added up together. Okay, so we're going to go ahead and take all of our side lengths and add them up together to see if we can come up with our total perimeter. So first we have up top, we have 2x plus 10. So we can say 2x plus 10, and this is all going to be p equals for perimeter. 2x plus 10 plus 3x plus x plus 3 plus x plus 7 plus 3x plus 10 plus our last side of just 10. Now, in order to simplify our perimeter, we need to make sure that we combine all of our correct like terms. So the first thing I'm going to do is I'm going to underline each of my terms that have an x in it. So I have a 2x, a 3x, a 1x, another 1x, and another 3x. So when I'm simplifying my perimeter is 2x plus 3x is 5x. 1 more is 6. 7, 8, 9, 10. So I have 10x. And then if I do the same thing with my constants, my whole numbers, I have a 10, I have a 3, I have a 7, and then I have 2 more 10s. So 10 and 3 is 13, 7 more is 20, 10 more is 30, 10 more is 40. So my perimeter would be 10x plus 40. And that would be the solution that I'm looking for. So I had to use my knowledge from 9a to go ahead and find the perimeter of a shape when something's missing. The first thing I had to do was find my missing side, this x plus 7 and the 3x minus 10, and then I took all of my sides and added them together. Now, perimeter is only one portion of what we're asking you to do. The second thing that we'd like you to be able to do is to be able to find the area given particular shapes. Now, one that we want to make note of is to find the area of a square. Now, in this case, we're given that one of our side lengths of our square is x plus 5. We know, because it's a square, that all of the sides are the same thing. So we know that this side would be x plus 5, the bottom would be x plus 5, and the other side would be x plus 5. Okay? And we also know from recall that the equation for area equals the length times the width. So in our case, our length is x plus 5, and our width is x plus 5. So in this case, we have our area equals x plus 5 times x plus 5. So here's where that multiplying of polynomials comes into play. So again, when we do this, we want to make sure that we build our box. So we're here, and we have our 4 quadrants for this. And up top we have our length, so x plus 5. And down in the bottom we have our width, so x plus 5. And we're going to go ahead and start filling in our area. So x times x gives us x squared. X times 5 gives us 5x. X times 5 gives us 5x again. And last, 5 times 5 gives us 25 in this bottom box. Now, we look for and identify that these 5x's are like terms so we can combine them. What that tells us is that in the end, our area equals x squared. 5x and 5x makes 10x, so plus 10x plus 25. So we have written a polynomial expression to represent the area of the square we were initially given. Now, that's just one particular example, but occasionally you will see an example where you're asked to find the area of a polynomial like we did in the first example. That is where we have some unknown dimensions and unknown sides. Now, here is where it gets a little bit on the tricky side. So if we go back, we can look back at 2 pages ago, and we can see that we knew that one side was x plus 7, and the other missing side was 3x minus 10. So we know that this side was x plus 7, and we used that from our notes earlier. And then we know that this side here is 3x minus 10. Now, we need to be able to break this shape up into 2 rectangles that we can use to go ahead and find area. So what I'm going to do is I'm going to choose to break it up using this particular line here. So I have one rectangle here, encompassed by this part, and I have a second rectangle over here encompassed by this second part. Now, you could have broken it up differently as well and drawn a line across and cut it into two separate rectangles, but either way will work. So for area, remember, we're going to go back and remember that our area formula equals length times width. And so we have to find the area of two separate rectangles and then add them together to get the total area. So in the case of rectangle 1, our area is going to be 10, our length, times x plus 7, our width. So the area of rectangle 1 the area of part 1 is 10 times x plus 7. Now, we just distribute the 10, so our area is 10 times x is 10x, 10 times 7 is plus 70. So our area is 10x plus 70 for the first part. Now, the area for the second part is going to be our long side, 3x, times our short side, x plus 3. Now, like we've talked about earlier, we don't actually need this 3x minus 10 because it only represents from there to there. We need the whole length. So we're going to use 3x, and then we need x plus 3. So our area for part 2 is 3x times x plus 3. Now again, we're going to go ahead and distribute. So to get our area, 3x times x makes 3x squared, because remember x times x always gives us x to the second power, or x squared, and 3x times 3 gives us 9x, so that's plus 9x. So we have the area for part 1, and we have the area for part 2. However, our question was, can we find the total area? So, total area is equal to these two added together. So it would be area of 1, which is 10x plus 70, plus the area of part 2, 3x squared plus 9x. Okay? Now, again, I'm going to go through and combine like terms. So I'm going to look for my x squareds. Here I just say I have 1. So my total area is going to be 3x squared. And then I'm going to underline all of my x's. So 10x, 9x, which makes 19x, so plus 19x. And lastly, I just have this plus 70 hanging out, so I'm going to put plus 70. So my total area equals 3x squared plus 19x plus 70, which is the final answer I am looking for. Now, these are just examples of problems that you can see. You might have other shapes, but in most cases, you can break them up into rectangles and shapes that you know to help derive what the area or perimeter might be. However, before you go, I want you to try one example of a practice problem. In this case, I would like you to be able to write a polynomial expression to represent both the area and the perimeter of the following shape. The one thing I will point out is that this green line here means that this distance is x plus 1, and it's the same on both sides. Good luck, guys.